Alright, this next lesson is 4.3. We're going to use matrices to perform the following operations, and this time they're not given in every problem. We're using just this set of matrices here that are given to us for all of these problems below. So matrix A refers to the one listed there under A and B and C and so forth. So that's a little different, but that's the way a lot of problems will be given to you on your test. They'll just have a list of matrices and you'll have to look and see how to work with those. So let's go on. Here we want to do A plus E. Well, first you have to look because, remember, in order to, I'm going to get rid of all those highlights. Remember, in order to add matrices, they have to be the same dimensions. Well, A and E are both 2 by 2, so we can do that. So let's write down here what we have. We have matrix A, which is -1, 4, 5, 7, plus matrix E, which is 3, 9, -1, and 0. And to add, all you do is add the elements in the same position together and get your answer matrix. So adding is really pretty straightforward. You have -1 plus 3, which will be 2 in that first spot. In the upper right hand spot we have 9 and 4. 9 and 4 is 13. We have 5 plus -1 or 4 in the bottom left spot, and 7 plus 0 or 7 in the bottom right spot. So those were fairly easy. Now on number 2 we've got a multiplication by a scalar. I'm going to erase this stray mark. 2 times matrix E. So you have 2 times 3, 9, -1, 0. And I'm going to say plus -3 times, because it's minus 3A, -1, 4, 5, 7. Okay. And then that gives us 2 matrices we're going to have to add together. So 2 times E is going to be 2 times 3 or 6. 2 times 9 is 18. 2 times -1 is -2. And 2 times 0 is 0. That's my 2 times E. And then we multiply -3 times the next one, which is going to give us -3 times -1 or +3, -12, -15, and -2. Now I like to multiply, change that to a negative and multiply by the negative, so then I can just add them, and that helps me avoid mistakes with negative numbers. Then I just add these 2 matrices that I've multiplied by the scalar together, just like we did in number 1. 6 times 3 is 9, 18 plus -12 is 6, -15 and -2 is -17, and 0 plus -2 is, well, what did I do here? -3 times 7, that should be -21, which I don't have there. So that's -21. Okay. Alright, so now we've got 3, which is B plus C. Well, let's look at B. B is a 2 by 3 matrix, and C is a 3 by 2 matrix, so they're not the same dimensions, so it's not possible. This one is not possible because to add they must be the same dimensions. To add now, if you just write not possible, that's good enough for the answer for this problem. B times C. All right, remember we have to check our dimensions here, so let's do that. B again, is 2 by 3. So I'm going to write them over here in the blue. And C is 3 by 2. Well, in this case, that difference makes them where we can multiply them because our inner dimensions match. And our final answer matrix is going to be 2 by 2. So let's first write down the matrices that we're going to multiply. B is 0, 1, negative 2. And negative 3, 6, negative 1. And C is negative 7, 4, 5. And then 3, negative 2, 2. Okay. Now we're going to multiply again row by column. We did that last in 4, 2. So we have 0 times negative 7 is 0, plus 1 times 4 is 4, plus negative 2 times 5 is minus 10. Then we have our second row. Okay, whoops, I didn't mean to erase all of that. Okay, we still have 0, 1, negative 2 here. We have our second row here times our first column. Negative 3 times negative 7 is 21, plus 6 times 4 is 24, and negative 1 times 5 is minus 5. Okay, so let's see if I can... Well, I thought I was able to erase those last time without erasing everything. Okay. So let's look now at, we're going to, we don't need this column, first column anymore. So we're going to go to the first row, second column. I'll change my highlighter a little. So we're going to go first row, second column on this one. So to multiply that, we end up with 0 times 3, which is 0, plus 1 times negative 2, which is negative 2, and negative 2 times negative 2, which is negative 4. Okay, then bottom row, can't seem to get this moved over. I want to see it. Okay, bottom row, so that's, I'm going to highlight a different color. We want it in, I'll do this one in blue. We want this blue row now times that column. Okay, so we have negative 3 times 3, which is 9, negative 9. And 6 times negative 2 is minus 12. And negative 1 times 2 is minus 2. And so all that then adds to be a 2 by 2 matrix, which will be negative 6, negative 6, 40, and negative 23 when I add all of those together. Okay, let's go to our next page to look at these problems. Now we have C times B. Well, C is a 3 by 2 matrix. C is 3 by 2, and B is 2 by 3, which means that our answer matrix is going to be 3 by 3. So we have C, which is negative 7, 3, 4, negative 2, 5, 2, times B, which is 0, 1, negative 2, and negative 3, 6, negative 1. Okay, so we're going to do negative 7 times 0, which is 0, plus 3 times negative 3, which is positive 9. Okay. 3 times negative 3 is negative 9. All right, negative 7 times 1 is 7. Plus 3 times 6 is 18. And then negative 7 times negative 2 is 14. Plus 3 times negative 1 is negative 3. Then 4 times 0 is 0. Negative 2 times negative 2 is 6. And going across, 4 times 1 is 4. Plus negative 12. And in the next one we have negative 8 plus 2. Bottom row in the matrix will have 5 times 0 is 0 plus negative 15. I'm sorry, that's going to be 6. It's negative 6. We're doing negative 3 times 2. Then we have 5 times 1 is 5 plus 12. And 5 times negative 2 is negative 10 minus 2. Okay, and then our answer matrix, when we add all those together, comes out to be negative 9, 11, 11, 6, negative 8, negative 6, negative 6, 17, and negative 12. Okay. C times D. Well, let's look at our dimensions. C is a 3 by 2, and D is a 3 by 3. These numbers don't match, so C times D is going to be a not possible. Okay? D times C is 3 by 3 times 3 by 2, and so then 3 by 2 is my answer matrix. So let's multiply that. We have negative 2, 5, 6, 4, negative 1, 0, 2, negative 3, negative 1, times negative 7, 3, 4, negative 2, 5, 2. Okay, so here we have our answer matrix. I'm going to try to show some work. 2 times negative 7 is 14, plus 5 times 4 is 20, plus 6 times 5 is 30. Going row times column. I'm just going to mark this one time. We've gone row by column. Then we'll do row times the next column for our next entry. That same row times the following column. So you have negative 2 times 3 is negative 6. 5 times negative 2 is minus 10. And get rid of that since that's going to be negative 10. And then 6 times 2 is 12, plus 12. Okay? Middle section, 4 times negative 7 is negative 28. Negative 1 times 4 is minus 4. 0 times 5 is 0. Then down in this next spot, that's plus 0. Write that a little clearer. Plus 0. Now in the next spot, we've got 2 times negative 7 is negative 14, plus negative 3 times 4 is going to be negative 12, and then negative 1 times 5 is minus 5. Up here in the middle, you're going to go back to the middle row times the second column. 4 times 3 is 12. Negative 1 times negative 2 is plus 2. And 0 times 2 is 0. And then 2 times 3 is 6. Negative 3 times negative 2 is plus 6. Negative 1 times 2 is minus 2. And then those will add to be 64, negative 4, negative 32, 14, negative 31, and 10. Okay. Now here's another type of problem where you have variables. Again, they're equivalent matrices because of the equal sign, and so the corresponding values have to be equal. This 2x, because they're in the first spot, notice the dimensions are the same, so those elements in the same spot have to be equal. So 2x equals 10, so my x is 5. Okay? That's one of them I have to know. Now we can go and look for another equivalency. Let's go here. And, okay, 4 is y minus 3. That's only one variable, so that's easy to solve for y then. 4 equals y minus 3. So if I add 3 to both sides, y is equal to 7. Okay. Well, I look at this next one then. It has two variables, but I know what one of them is. So let's find another color. This one we're going to look at here. It says that w plus y is equal to 8. Well, I know that y is 7, so w plus 7 equals 8. Subtracting 7 from both sides, w then is equal to 1. And the last variable I have is in this middle column on the bottom, in bottom row. And it will go 3z plus 1 is equal to 2z minus 1. And if you look, if we go on, two equals 2 as it should, and 0 equals 0. We don't have to do anything with those. We just need to go back and solve for that last variable, z. So 3z plus 1 is equal to 2z plus minus 9. So I'm subtract 2z across, and I have z plus 1 is equal to negative 9. And when I subtract 1 then, z will be equal to negative 10. And that's how you solve for variables when they're in matrices like this.